So I want you, before I give you the topic for today, I want you to look at the following table. 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st. And I want you to think about what those actually equal. So if I gave you 2 to the 4th, what does 2 to the 4th actually equal? 16. 2 times 2 times 2 times 2 is 16. What is 2 to the 3rd? 8. What is 2 squared? 4. What is 2 to the 1st? 2. Okay, now, look at both columns and look at the pattern that is forming. Don't say anything, but look at the pattern that's forming. And just look at it for a second. If I asked you for a general statement on what is happening up there, what would you tell me?
They keep dividing by 2.
What do you mean, what keeps dividing by 2?
Each number, like after, the first one, the second one, the third one, the fourth one.
I'm looking for something a little bit more, I want you to say it a little bit more specific. There's a specific way I want that said.
Every time the power number goes up, the numbers duplicate?
Okay, reverse it because the pattern starts at the top and goes down. So I want you to think of it a different way. And I'm trying to get you something specific out of you.
Every time the power decreases, the number is divided by 2. The solution is divided by 2.
Okay, so every time, and not the power, but every time the exponent decreases by 1, the answer is divided by 2. That works for this one, and we'll talk about why that doesn't work in a second, but that does work for this one. In that case, if that is true, then if I asked you, what is 2 to the 0, what would you tell me?
1.
I hear two different answers. How many people say 0? How many people say 1? It's about 50-50. In all honesty, if you do it correctly, if every time the exponent decreases by 1, I've divided by 2, to go from 1 to 0 is a decrease by 1, correct? So then 2 divided by 2 is equal to 1. Now, if I gave you 2 to the negative 1st, what would you think that is? That is a half. What about 2 to the negative 2nd?
A fourth.
It is a fourth.
I'm so confused.
And how about 2 to the negative 3rd? An eighth.
This game's scary.
Now, we're not going to go to the 16th for a second, but just hold on. But if you look at what we're doing, every time the exponent decreased by 1, the answer was divided by a half, or divided by 2. So 2 divided by 2 gave me the 1 for 2 to the 0. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4, and 1/4 divided by 2 is 1/8. Okay, now, let's look at this pattern. 3 to the 4th, 3 cubed, 3 squared, 3 to the 1st. If we do this, what is 3 to the 4th? Anybody? It's 81. And 3 to the third? 27. And 3 squared? 9. And 3 to the first? 3. Now, if we continue that, if you look at the pattern, let's talk about the pattern here for a second. If I use what we said before, as the exponent decreases by 1, I divide by 2, that's not true. What is it this time?
For whenever the exponent decreases by 1, you divide by 3.
Okay, so this time you're saying every time the exponent decreases by 1, you divide by 3. Can we come up with something a little bit more generic that I could use for any pattern I come up with?
As the exponent decreases, the base number will be the answer divided by 3 since it's the same multiplied, but you're just taking one away so it's divided.
No, that would be the base number divided by the base number.
Kind of, but I'm looking, you're almost there. Almost there, I think you mixed up a couple of words. So that's what we're trying to get at.
If you want something generic, it would just be every time the exponent decreases, your number is divided by the base number.
That's what I'm looking for. Every time we decrease the exponent by 1, the answer is divided by the base number. So, what is, by the way, 3 to the 0? 1. What is 3 to the negative first? 1/3. What is 3 to the negative second? 1/9. What is 3 to the negative third? 1/27. Now, it does.
I don't really understand, for like the, because when you do the exponents for like 0 and like negatives, I don't really understand how that's actually those answers versus 0. Because I don't really understand how you would divide instead of multiply. I don't really understand.
I'm not sure I understand your question.
I know you're saying divide on that side and multiply on that side. I don't really understand how you got
You don't multiply. You're always dividing.
You're always dividing.
You're always dividing.
Divided by 3.
No, but I don't understand.
When you're going up, you multiply.
How I got 1? I'm always dividing by 3, right? So what's 3 divided by 3? 1. That's how it gets to 1.
I mean, I get it, but, I mean, isn't exponents like you're timesing the number by however many times the exponent is?
Interesting question.
So wouldn't it be?
But here's the thing. And the topic is negative exponents. Today's topic is negative exponents. And the fact of the matter is, negative exponents do not do the same thing as positive exponents do. So yes, if I had 2 to the third, you're right. That is 2 times 2 times 2. Absolutely correct. But negative exponents don't work the same way. But the thing is, and the trick is, we want to get rid of negative exponents. Now I'm going to contradict that on the homework tonight, but I'll show you why later on. The trick is to get rid of negative exponents altogether. But I want you to look at something for a second. Look at, nope, not that. Come on, erase, there we go. Look at when we said 2 to the negative second and 2 to the negative third. 3 to the negative second and 3 to the negative third. I want you to consider, we said 2 to the negative second was 1/4, correct? Look, Bell. Okay. But think about the 4 for a second. What is 4?
Oh, it's 2 times 2, but I think the slash would be the negative for the slash over the. Like, still, like this.
You're jumping way, way, way ahead of me. What is 4? It's 2 squared. This is 1 over 2 squared. We said 2 to the negative third was 1/8. But what's 8? 2 cubed. We said this was 1/9, but what's 9? 3 squared. We said this was 1/27, but what's 27? 1 over 3 cubed. Now, if you're noticing the pattern, then what you're ready for the rule. And the rule says what? Oh yes, the rule says that. The rule says a to the negative nth power is equal to what? A to the negative nth power is equal to what? Mm-hmm.
One over a that negative, or a over the number. What? It's the 1 over a of the exponent.
Okay, 1 over a to the nth power. Whenever you have a negative exponent, we can make it into a positive exponent by going 1 over a to the nth. So if I gave you 7 to the negative 9th, I could rewrite that as what? 1 over 7 to the 9th power. Absolutely. So that's what negative exponents are all about. Couple here. I want you to rewrite these so that they have positive exponents. Rewrite these so they have positive exponents. Figure out what these are with positive exponents and pause the recording. Pause the recording and figure these out. We're looking at writing these as with positive exponents. So 3 to the negative 5th would be what? 1 over 3 to the 5th. You do not have to evaluate that out unless I absolutely tell you to. What is y to the negative 3rd? 1 over y to the 3rd. What is 7 to the 0? 1. It's 1. We'll talk about that in a second. X to the negative 15th, what is that? 1 over x to the 15th. Now, ladies and gentlemen, 2 to the 0 was 1. 3 to the 0 was 1. 7 to the 0, I just told you, was 1. So let's come up with a special rule here. Any number to the 0 power is 1. Now, one of my favorite things I've done before, I did this to a class once. I gave them this problem. And the answer is 1. And the funniest thing is, I put this up on the board and I told my class, okay, start this, but do not say a word when you get the answer. And I watched, as soon as I put it up there, everyone's like, the heads all of a sudden go down. Everyone starts working, and you see heads start coming up. And the first 3 that come up were up in 2 seconds. They saw the 0, they knew it was 1. But then I have students working and working and work. And you get a few of them who have, work all the way through, and then they see the 0 and oh. And then you get the ones that work it, and it took 10 minutes on this. And they still didn't get 1, which blew me away, but they did. Now, here is an interesting question for you. If I said to you, and honestly in math, this drives mathematicians nuts, because we don't use negative exponents. So I don't know why this is asking you to do this, but it is. 1 over 6 to the negative 3rd power. Nope, sorry. Oh, no, I wrote that wrong. I was going to that's not make sense. If it was 1 over 6 to the third, how would you write that with a negative exponent? How would you write that with a negative exponent?
6 with negative.
Yeah, this would be 6 to the negative third power. I'm just reversing the rule around. But here's an interesting one. How would you write this with a negative exponent, but the negative exponent cannot be negative 1? How can you write this so you do not have a negative exponent? So you have a negative exponent, but your negative exponent cannot be negative 1.
5 to the negative second.
Yes. Because this really is 1 over 5 squared. I've prime factored that, which is 5 to the negative second power. Huh?
Yeah.
Yes, you're allowed to do that.
No, I
Okay. Here, do this one. Let's try this one. 1 over 64. Write that as a negative exponent, but you cannot use negative 1. Because we all could do 64 to the negative first. And I'm curious what you get on this, because I'm going to tell you there are actually 2 different answers on this one. Huh? Ah, interesting. There are 3 answers. I missed one. One of those answers could be 8 to the negative second, because 64 is 8 squared. What's another possible answer I could do for this one?
4 to the negative fourth power.
Is it 4 to the negative fourth?
Six.
It's 4 to the negative third. It's 4 to the negative third power. Or, there's one more possibility. 2 to the negative
I don't think that would work.
negative 6 power. So there are a variety of different answers I could have done depending on how I factored the different things. But in all honesty, they're actually all the same. But I'll explain that another time. All right, look at this problem for me. This is an interesting one. Evaluate 4a to the negative fifth if a equals negative 2. Pause the recording and see if you can figure this one out. The way we do this problem, if you did it right, what you have to realize is exponents are very, very specific. And when I say specific, I mean they are attached only to what they are right above. So this problem truly says 4 times a to the negative fifth, which becomes 4 times negative 2 to the negative fifth, which is 4 times 1 over negative 2 to the fifth. Well, negative 2 to the fifth is just negative 32.
Dang you, PEMDAS.
And then the 4 goes into the negative 32 8 times, and you get that 1 over negative 8, but I like that negative sign to float up to the top to give me negative 1 8. And so that is the answer. So the answer is negative 1 8. Of course it will. Now, take a look at this question. Oh, I can't do that one yet, can I? Never mind, I can't do it yet. We haven't learned that.
Can we have another example?
Of that one? Sure, I can do another example of that one. How about we do negative 4 m to the negative second if m equals 4. Did it correctly? That's negative 4 times 4 to the negative second. which becomes negative 4 times 1 over 4 squared, which becomes negative 4 times 1/16. That cancels there, so what I get is negative 1/4. I can leave that up for a second. All right, we want 6m n to the negative 4th if m equals 4 and n equals 3. Try that one. If you did this one correctly, you would have done 6 times 4 times 3 to the negative 4th, which is 6 times 4 times 1 over 3 to the 4th. 3 to the 4th is 81, so this is 6 times 4 times 1 over 81. But 6, I can divide out a 3 out of each of those, so 2, 27. So I get 8 27ths.
How is it negative?